Welcome back to my YouTube channel, and in today's video we are going to be continuing our series on Laplace transform. So we are done with Laplace transform, the major part of Laplace transform itself, and now we are going to move on to inverse Laplace transform as a whole. So first things, I'm not going to be doing a lot of provings in this series of inverse Laplace transform. So we are just going to be, these are the things that we need to know for the inverse Laplace transform. And just so you know, the inverse Laplace transform is the opposite of Laplace transform. It's just like differentiation is to integration. Inverse Laplace transform is to Laplace transform. And that is the way it is. So now the inverse Laplace transform of k over s is going to give us k. And we remember when we were finding for Laplace transform, the Laplace transform of k is going to give us k over s. So it's in such a way, inverse Laplace transform is going to give us our answer back. And then we have Laplace transform of 1 over s raised to power n is equals to t raised to power n minus 1 over n minus 1 factorial. And yeah, this formula might seem a little bit different from what was its origin, because the origin was the Laplace transform of t raised to power n that gives us n factorial over s raised to power n plus 1. But if we are to find for the inverse Laplace transform of both sides, we have t raised to power n is equals to the inverse Laplace transform of n factorial over s raised to power n plus 1. Now, n factorial is a constant, so it can come outside of an integration sign. So therefore, it can come outside of the Laplace transform and come under here. So that is when we get t raised to power n over n factorial is equals to the inverse Laplace transform of 1 over s raised to power n plus 1. So from here, what they just did is they changed n to be equals to n minus 1, and when they did that, the entire answer is going to give us what we get here. So what you can see is that all of this is just an inverse form of the normal Laplace transform. So and that is it for the explanation of that. In this, you should know one inverse Laplace transform of 1 over s minus k is equal to e raised power kt. Inverse Laplace transform of s over s squared plus k squared cos k squared. Inverse Laplace transform of 1 over s squared plus k squared is equals to 1 over k sin kt. Yeah. So therefore, the hyperbolic function of cos and sine. So now, today we are going to be solving a question on inverse Laplace transform. So we have to find for the inverse Laplace transform of these two questions. We are going to start from one. So let's start from the first one over there. One. Now we have inverse Laplace transform, or let's first break it down. Yeah. Inverse Laplace transform of s squared plus s plus 2 all over s raised to power 3 over 2. Yeah, which is equals to the inverse Laplace transform of, we can, everything can have its personal denominator. We have s squared over s raised to power 3 over 2 plus s over s raised to power 3 over 2 plus 2 over s raised to power 3 over 2. In this scenario, we apply indices here, and this is going to give us inverse Laplace transform of s raised to power 2 minus 3 over 2, then plus s raised to power 1 minus 3 over 2. Then we also have plus, let's do this as 2 over s raised to power 3 over 2. So if we simplify this, we are going to have 2 times 2, 4. So this is going to be equal to inverse Laplace of s raised to power 1 over 2, then plus s raised to power minus 1 over 2, then plus 2 over s raised to power 3 over 2. So now, what major form can we find for the inverse Laplace transform? What is evident is something like this. So if we are to use something like this, that means s has to be in the denominator, and we know that when we are putting something in the denominator, it's going to have the minus sign to its power. So therefore, we can break this down as the inverse Laplace transform of 1 over s is power minus 1 over 2 plus 1 over s is power 1 over 2, then plus 2 over s raised to power 3 over 2. So now that we have broken it down to this, we can continue our inverse Laplace transform. So by continuing it, we have the inverse Laplace transform. Yeah. After finding the inverse Laplace transform, this is going to give us here we have t raised to power minus 1 over 2 minus 1 over minus 1 over 2 minus 1 factorial. That is for that. So we have plus c raised to power 1 over 2 minus 1 over 1 over 2 minus 1 factorial. And in this case here, we have plus 2t over, we have 3 over 2, raised to power 3 over 2 minus 1 over 3 over 2 minus 1 factorial. 3 over 2 minus 1 factorial. So now we might have a little problem here because this is fraction. So what you just need to do is to put this into gamma function. And you can check my earlier videos to see how I explained the gamma function and how to do solve gamma functions problems. So that is what we are going to be doing here. So this is going to be equal to, we have t raised power minus 1 over 2 minus 1, that is minus 3 over 2. We have it over here. The gamma function, now we know that gamma n factorial is equals to the gamma function of n plus 1. So we have minus 1 over 2 minus 1 over 2 minus 1 factorial is going to be equals to this gamma function here. The gamma function of minus 1 over 2, we have our minus 1 plus 1. Minus 1 plus 1 cancels each other in that sense. So therefore, we are going to be having the gamma function of minus 1 over 2 over here. So therefore, this is going to be equal to the gamma function of minus 1 over 2. In this case, you have t, here we have t is power minus 1 over 2, that is 1 over 2 minus 1 over the gamma function of 1 over 2, we will have plus 2t raised power 1 over 2 over the gamma function of 3 over 2. So that is it for that. And now we know that gamma function, in gamma functions, the gamma function of 1 over 2 is equal to the square root of pi over here. That is the gamma function of this. And this is the only defined or the majorly defined gamma function of a fraction. So we are going to be putting all this into terms of 1 over 2. So now for minus 1 over 2, we know that the gamma function of minus 1 over 2 can be expressed as the gamma function of, yeah, it can be expressed as, yeah, we have the gamma function. We can express it in such a way that the gamma function of 1 over 2 is equals to the gamma function of minus 1 over 2 plus 1. Yeah? This is equal to this because if we just add this to this, we are going to get the same answer. So, and we have another law of gamma function in this place, that is the gamma function of z plus 1 is equals to z gamma function of z. So we just put it here, and this is equals to the gamma function of 1 over 2 is equals to minus 1 over 2, the gamma function of minus 1 over 2. And at the end of the day, this is equals to square root of pi, and this is equals to minus 1 over 2. We have gamma function of minus 1 over 2. We make gamma function of minus 1 over 2, subject to the formula, we are going to be having the gamma function of minus 1 over 2 to be equal to minus 2 root pi. So that is what we are going to get here. So this will be equals to t raised to power minus 3 over 2 over here minus 2 root pi. Then we have our plus. For the other one, is straight and direct. We have t raised to power minus 1 over 2 over gamma function of 1 over 2 is root pi. We also have 2t raised to power 2. We have 2t raised to power 1 over 2 over now. we have the gamma function of 3 over 2. How are we going to express it in terms of gamma function of 1 raised to power 2 or 1 over 2? We know that the gamma function of 3 over 2 is equal to the gamma function of 1 over 2 plus 1. So, therefore, this is equal to 1 over 2 gamma function of 1 over 2, which is equal to 1 over 2 root pi. So, therefore, this is equal to 1 over 2 root pi. So, that is our answer for that. And if we simplify it all, we are going to get c to minus 1 over 2. Then we have this minus 2 here. It can come outside here. We have that minus c over 2 root pi. Then we have plus c to the minus 1 over 2 over root pi. Then we have plus, if this comes up, we have 4 c raised to power 1 over 2 over root pi. So this is going to be our final answer for the first question. So now let's move on to the second question. Now, moving on to the second question, we are going to have to break this down via the gamma inverse Laplace transform of 2s minus 5 over 9s squared minus 25. So we break this down, we have the inverse Laplace function, Laplace transform of, we can put it 2s over 9s squared minus 25. We have minus, we have 5 over 9s squared minus 25. So this now here, it looks like both of them can be squared. They can be in square form. So therefore, this is inverse Laplace transform of, we have 2s over 3s all squared is going to give us this minus 5 squared. We have plus 5 over here. We have 3s all squared minus 5 squared. That is for that. So therefore, now we want to put it, what is looking like here is looking like something like both this and this. But in these scenarios, s is standing alone and s is standing alone here. So we want to make sure that our s is standing alone here. So I'm going to have this as inverse Laplace transform. I have my 2s over, now if I bring 3 outside of here, I'm going to be having 3 square into brackets s square minus 5 over 3 all square. In this scenario, it should be plus 5 over the same thing here, 3 square into brackets s square minus 5 over 3 all square. So that is it for that scenario. And now we can bring our constant outside and we can even break the Laplace transform out. So we can have 2 over 3 square is what? 9. Inverse Laplace transform of this first one, s over s square minus 5 over 3 all square. We have plus, we have 5 over 3 square, 5 over 3 square, and 3 square is equals to 9. So inverse Laplace transform of 1 over s square minus 5 over 3 all square. So and that is it. This is the breaking down of the inverse Laplace transform. So what we just need to do is to apply our formulas here, which is our cos and our sine, the hyperbolic functions. So when we apply them for this, we are going to have 2 over 9, the inverse Laplace transform of, now this is going to give us what? Cos kt. So that we are going to be having, yeah, the inverse Laplace transform is going to give us cos, what is our constant? 5 over 3, 5 over 3 t. Yeah, and then for the second one, we are going to be having plus 5 over 9. And now is going to be multiplied by 1 over k, where k is 5 over 3. So 1 over 5 over 3, that is 3 over 5 sine kt. And our final answer is going to be 2 over 9 cos 5 over 3t plus 5 cancel 5 here, and 3 here 1, 3 here 3. We have plus 1 over 3 sine kt. So now this is the final answer for the second one. So that is how you get the inverse Laplace transform. Hope we all understood. Don't forget to subscribe, like, comment, and share. Thank you very much.